Okay, guys. Today we're going to look at law of cosines and how to apply it to navigation. You've got a couple of planes leaving an airport, and we're going to use course vectors to figure out how far apart they are after a given amount of time. The first one flies out of the airport at 250 miles per hour. I'm going to call this A for the airport. And hopefully you all measured 10 units because it's going to fly for 2 hours at 250 miles per hour. So it's going to go 500 miles. If I count out 10 units, it's this far. Now, if I were doing actual navigation and, I was on my boat or I was looking at my course on a boat, I would actually use my compass to do the measuring on the map. But we're going to go ahead and use this one. We're going to use our note card. And this is 10 units, so this is 500 miles. I'm going to go ahead and use the scale that each one of these represents 50 miles. And it doesn't specify the direction that the first airplane left. If it gave me a direction, then like a course direction, then I would show you how to measure that. As it is, it doesn't matter. I can put it at whatever angle I want. I'll just put it up here. This long. This is my first vector. This represents 500 miles. It says that there's an angle of 65 degrees between the two planes. So I'm going to measure 65 degrees. If you haven't done that, make sure you measure 65 between. It's right here. And this time, this plane is flying 325 miles per hour for 2 hours. So he's going to go 650 miles. This is 500 and 3 more make 650. So I'm going to measure this. Right here. 650 miles. Where this is 65 degrees. Anytime you have a side, an angle, and a side, you can find the distance between the planes using law of cosines. I'm going to measure this distance between these guys. At the end, I'll actually measure it physically. We're going to do it using the law of cosines first. For you guys, I called this C and this one B. And that means that across from angle C is side C, and across from angle B is side B. And we want to find the distance between the two planes, which we're going to call A because it's across from angle A. Write your law of cosines, starting with A squared. Everybody write it from memory as best you can. Aldo, put the phone away. Corbin, you're not going to do this? Okay. Do it next year, I guess. All right. A squared equals, just like the Pythagorean theorem. Bless you. We have B squared plus C squared. And the only thing you have to remember is that you've got a minus 2 and then BC. The B and C are the ones we know. And we also happen to know the angle A across from A, so we call it cosine A. This is the law of cosines for the one we're doing. If this had been C, then I would have started with C squared, and everything else would have been the same relatively anyway. Now, we could put these numbers in here, and I could substitute. Instead of B, I can put the 500. Instead of C, I can put the 650. Instead of B, I have 500, and the 650 for C, and the cosine of A is the cosine of 65 degrees, and I can evaluate this. What you need to be a little bit careful of is that you're going to get the 250,000 for this, and then you're going to get the 425,000 for this one. Oh, okay. Well, I just substituted these in. I just substituted for B and C and B and C and A. I just put the values in. However, we're not going to do it that way. I would much rather just put them in my calculator and let the calculator do all the work. So what I'm going to do, I'm going to put 500 for B, and we do that by putting in the value 500, and I'm going to store it. That's the STO key just above the on. It's right there. Looks like a little arrow, and then I have to use alpha B. Until I change it, B is now 500. I would have preferred to use the little b, and I could have done that. It's just that the calculator is a little hard to get to. It's kind of hard to find those little ones. Put in your other values, and then we'll evaluate. Okay. Okay, well, you can watch this. I'll upload it. All right, the next one is I'm going to call C. So 650 is going to be C. I'm going to put 650 and then store alpha C. So now B is 500, C is 650, and my angle A is 65 degrees. I'm going to store that as A, and I'm all set. All I need to do now is put in my formula, which is B squared, oops, let me put it where you can see it, B squared plus C squared minus 2BC cosine A. And that's going to give us A squared. Just keep in mind that I'm going to be finding A squared, not A. So I do B squared plus C squared minus 2BC cosine A. We could program this in like we programmed in the volume formulas and the surface area formulas for cylinders and cones, but it's pretty easy to substitute this in. And you press enter and you get 397,798. This is not the distance A. This is A squared. I'm getting 397,798 approximately, and I need to take the square root to find A. Two ways to do the square root. You can use the square root key, which is above the x squared. So I can press second square root, 397,798. And I get about 630 my answer. Your other option is that instead of a square root, you can use it to take it to the power of 1/2. I use the power key, which is this little arrow key, to the 0.5, and it'll give you the same answer. I get about 630 miles for the distance between them. The other way to do this problem is to just simply measure it. Measure that distance between these guys. That's what I'm going to do. I'm going to measure from C to B. I'll put it in the middle here. There. C is right there, and B is right there. And I want to see how close I get. Try yours. See if you get the same thing I do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and just a little more than halfway. I get about 12.5 or 12.6, and each one represents 50 miles, and that gives me 630 miles. Pretty close. Now I'm going to have you guys do one more problem on your own. It's going to be a parallelogram. This, by the way, was number 1 from one of your worksheets. Number 4 is a parallelogram. One side was 23 centimeters. Another side was 15 centimeters. And one of the angles was 42 degrees. So what I'm going to do is, in one of the other classes, I tried to draw this 23 squares by 15 squares, and it didn't quite fit in the paper. It was just a little tiny bit too big. So what I'm going to do, I'm going to use 11.5 units for this one and 7.5 units for this one, and make each one of the squares represent 2 centimeters instead of 1. Go ahead and draw a parallelogram. One of the sides is going to be 11.5. One of the angles is going to be 42 degrees. I'm going to start here. I'm going to make this 11.5. Right there. And I want a parallelogram. This is going to represent 23 centimeters. Remember, each one of these is going 2 centimeters. Now I'm going to do 42 degrees from here, which is right about there. And I'm also going to do 42 degrees from here. It's right about here. And I want to make it 7.5 long. Where are you going? This one is 7.5. This one is 7.5. And this should be 11.5, and there's a way to tell. I just take a look and see. Let me see. I'll just measure it with this one. I want to make sure I'm actually at the right length, and I am. That is 11.5. Now this angle happens to be 42 degrees. And what they asked me for was the length of the longest diagonal. Now, if I wanted the short diagonal, it would be real easy. I could use this side, this angle, and this side and do law of cosines. They actually want me to find this distance over here, though. They're looking for the long diagonal. And it's across from this angle. So you need to find this missing angle for a parallelogram, and then you can find this missing side. I'm just going to go ahead and call this A, just like we did before up above. And I'll just use these B and C. I'll call this one B and this one C, and it's going to have the same, you're going to solve it in the same way that we did up above. So give it a try. This angle's 42. This angle's 42. This angle is the rest of 180. What is it, Marcelo?
138.
138. And we now have a side, an angle, and a side, and we want to find the A, just like before. Write your law of cosines, find your side A, and then what I'd like you to do is actually measure it and test it to see if it's the right length. Okay, go ahead.